Okay, in Chapter 9, we're going to talk more about managing quality. Chapter 8, we defined it, gave an overview to it. Now we'll get a little more into some of the tools that you use to implement and manage quality with. And some of them you should recognize from previous chapters that we've mentioned in them. And it starts with the design of quality and gets into the processes, different dimensions of controlling the process, and getting into some of the tools such as continuous improvement, Six Sigma, and lean operations in order to manage it with. And the first part is the definition of a process and how do you design it. When looking at a system or a process, part of your definition is to identify critical points, especially in processes where they are inventory related. And an example of this is one critical point is receiving the material, the incoming materials, and even the services fit into the same concept. Then there might be a separate category, especially in inventories, while that material is being worked on or transformed, as we referred to it in earlier chapters. We call that work in process. And what you're doing, you're adding value each step along the way as you're adding something to that. Finally, when you finish it, we call that finished good product or finished services, and that's a third category. That is the category that most organizations try to minimize under just-in-time or lean manufacturing, because that's where they build up too much costs. If they complete the job and they don't have a sale for it, it stays in their inventory, and who knows, it may become obsolete at that point. In order to design your systems and eventually to control them, you look at different elements of them. One of them is you try to identify what variables are involved in the process, and then you try to look at the attributes of the system as well and help make some decisions, one of them being how much inspection do you need. Some systems, highly designed quality systems, need no inspection. Others, by definition, probably need it. What is an attribute measurement? It's a characteristic that's evaluated with a discrete measuring choice, such as good or bad, yes or no. You're forced to make a type of a decision, such as a no or a no-go type of decision, before you can move on to the next step. On the variables aspect of it, you're looking at characteristics that can be measured continuously. So examples like length, size, weight, height, all that stuff. On a continuous basis, there's a consistency to that. As much as we don't advocate inspection, there are things that when you do have inspection, you have to keep in mind. Defective items is one of them. Obviously, everyone's goal is to minimize that. Correction of defective items is another thing, which says you don't just scrap everything when it's wrong. You look to see, can it be fixed and for how much? But more important is what we call prevention, and that says, what are some of the things we can do in the process to prevent the defect from happening again? And that kind of leads us into the fourth element, which is continuous improvement. We always want to keep, whatever we do, no matter how good we think we are doing it, we always have to ask ourselves, how can we make it better? I call that the Olympic athlete thinking, because most Olympic athletes are never satisfied even when they break records. They're always thinking about how they can beat that record the next time. What happens when you find a defect? Well, there's a lot of things that you have to look through, and we need to be careful that we don't put this all on the inspector's responsibility. Usually we look at the inspector to identify the defect, but then the corrective action may have to be, again, in other parts of the organization. You do have to pull it from a production line and decide, can it be immediately fixed, or does it have to go back to design or some other area to be re-engineered? You have to analyze it in terms, especially finding out root causes, and try to see whether you have to change your system or is it just this one unit that has to be corrected. And you have to make sure on an ongoing basis that you have systems and control in place to continuously monitor the process of the system. There are what we call tenets or basic assumptions any quality control system should have. And by that we're saying most processes, almost every one of them, have some degree of what we call random variation. In other words, recognizing that something isn't perfect 100% of the time, you try to define for yourself what percent of variation can I have and still be acceptable. So in a spacecraft world, that answer is very little. In other types of processes and productions, you may cut some slack. You can go up to 5% variation, say, again, back to the old saying, good enough for government work. Production processes have different degrees of control, depending on whether they're repetitive processes or job shop-oriented processes. But even there, they should all have some degree of control. What you want to do is focus on the variation and reduce it or eliminate it as much as possible. As you can see in this quote by Bill James, the objective of any quality person is to eliminate the randomness out of anything possible so that you can control and get your hands on the rest of the defects which are under your control. What you want to do is identify the causes that can be assigned and corrected. As we just said earlier, try to isolate the random effects from the things that are controllable and can be redesigned in the process. We said earlier, attributes are things that you can measure, and variables are measures themselves which define ranges of deviation. That's where you get the things like the bell-shaped curve and other tools that give you an idea of how much deviation you have in your process, where and when. And we will talk about all this in the chapter. There's different ways you can implement control. You can use different types of control charts, and different ways of testing them. One is sample sizes, which means that you don't check every single item that gets produced. But that leads to questions of how often do you sample and to what degree. There's other issues with the type of process or the type of tools that you use that have to be answered. Continuous improvement, I mentioned it just a few minutes ago. I like to describe it in context of the Olympic athlete type of thinking. It just says it doesn't matter how good you are. You could be very good, you could be very poor. But wherever you are on that scale, continuous improvement tries to promote the attitude that you're always going to keep improving and getting better. And there are different tools that you can use for some of these aspects of quality control. Flow charts, histograms, Pareto charts, especially cause and effect diagrams and scatter diagrams. There's not one of them that's really the panacea to everything. You have to apply it where it makes sense. There are different results you get from different applications, but most of the time you will see the results in the bottom line of increased or decreased effectiveness. Six Sigma, very popular, very recognized as a tool. It's a misunderstood tool to some degree because some people remember that we used to preach a lot of total quality management, or TMQ as we call it, and many people think that Six Sigma is replacing TMQ. Well, that's incorrect. TMQ is a philosophy. It's a comprehensive type of thinking to all quality dimensions. Six Sigma is a tool that specifically deals with implementing quality in a particular way. It's based mostly on statistical evaluation with the attitude that says, TQM might have been too broad, too conceptual. We need to have more precise measurements, and here's one way we do it, is with Six Sigma. There's a DMAIC process that is promoted in this thinking that says there are 5 steps you go through for Six Sigma. They're recognized as define, measure, analyze, improve, and control. You always have to remember a checklist, so to speak, to use that. Six Sigma is usually implemented in a project or team approach. It's usually focused on processes, emphasizes again the cross-functional participation of teams, and it identifies itself with a few incentives, so to speak, such as black belt or green belts and different color belts as the way of evaluating the degree of excellence in quality that you have implemented. Six Sigma and lean concepts go hand in hand together because, as we said, Six Sigma is really the evaluation process and a way of getting more definitive measurement, but it's not necessarily the way you solve problems totally. And so what you have to do is turn to things like the lean concept to say, okay, how do you actually implement some of these concepts? Lean, as we said, tries to eliminate waste, while Six Sigma focuses on eliminating the defects or the statistical or numerical part of it. They work very well hand in hand together. As you can see, industry of all types are using more and more statistical analysis, more quality control techniques to improve their quality and improve their defect issues, and they're not relying so much on qualitative or subjective valuations such as impressions of suppliers, like I like this supplier, but I don't need all the numbers to tell me that they're a good supplier. So we're just trying to quantify more of this process.